Hello there. In this video, I want to talk about writing linear equations. And in one of my previous videos, I went ahead and I showed you how to graph equations, primarily in the form y equals mx plus b, where m is our slope and b is our y-intercept. But I want to take a look at not necessarily graphing it, but what if we have certain criteria and we want to write an equation that's in this form? And there's only going to be two examples in this video because there's really only two kinds of examples that we can work through when we're just bare bones writing an equation. The first one is on the board. It is find the equation through the point -3, -4 with a slope of 2. So this is one of the criteria we could be given. We could be given a slope and a point, okay? All right, so I'll start with the idea that we have our slope, it's 2, but we don't have our y-intercept. Remember, y-intercept would have an x value of 0. So if we were specifically given a point of 0 comma something, then that would be golden because we just plug it into this equation and we'd be done. But we don't have that. So I'll start writing my equation as y equals 2x plus b. Now, there's a couple ways I can solve for that y-intercept. And without graphing, because I don't want to resort to estimating, I want to get the exact answer. I'm going to go ahead and I'm going to plug in -4 for y from my point. I'm going to plug in -3 for x. And I'm just going to solve for b, because now I've got a fairly simple equation. I can solve for the variable at hand. Okay, so I know I'm going to do this first. I get 2 times -3 is -6 plus b. And then I'm going to go ahead and add 6 to both sides. These will cancel. And -4 plus 6 is 2. And that is my y-intercept. So when I write my final equation, I'll write y equals, my slope was 2, so 2x. And then my y-intercept was also 2, plus 2. Now, the other way we can work through this, I'm going to go ahead and get rid of this work, is to use what's called point slope form or vertex form. Now, the choice is up to you. I'll show you what point slope form is. Point slope form is y minus y1 equals m times x minus x1. Now, I'm not a big fan of this form simply because it requires two y variables or things to be on the same side of the equation at the same time. So what I like to do is add y1 to both sides, and this will cancel, and then I get y equals, and now this starts to look more a little bit like a linear equation. Now, it's still technically point slope form, but sometimes we will see other equations written like this, and we call them vertex form. So that's what I'm going to go with. I'm going to go with the name vertex form. And if we wanted to use this method, I'd start by writing y equals, again, my slope is 2, and x and x1 are just the values that are given to me in the point. So I'm going to write x minus, and my x value, that was -3, so a -3 there. Okay, I'm going to write plus, and then my y1 was the -4, so I'm going to write plus -4, which will be -4. Okay, so I know that this right here will become a plus, and I know I have to distribute the 2. I get y equals 2x plus, because we got the plus there, 2 times 3 is 6, and then plus a -4, so that'd be -4. And then we can just simplify these, and we get y equals 2x, 6 minus 4 is 2, and lo and behold, we get the same thing we did before. So that's one type of criteria. You could be given a slope and a point, in which case both of those are perfectly acceptable methods for finding a linear equation. I prefer using the vertex form because it looks nicer, whereas with using slope-intercept form, I have to plug in the numbers, I have to do the math, and then it's kind of like I have to backtrack and plug it back in. It's not really that big of a deal. It's just personal preference. All right, let's go over one more example. In this, we're given 2 points. So we could give the slope and a point, or we could just be given 2 points. Now, since we're not given slope, we need to know how to calculate slope. So slope, remember, is the rise over the run, as it's known colloquially, I can't say that word, as it's kind of known for slang. So this is the change in y over the change in x, okay? And think about it. When we were doing this on graphs, it was just counting. We were counting up, down, left, right, okay? So that means we're basically moving from, when we're moving up or down, we're moving from one y value to the next. So what we do is we'd say this is taking the difference of two y values. So in notation, that's known as y2 minus y1, okay? And the change in x is x2 minus x1. Now, when you're given 2 points, it doesn't matter which one's x1, y1, and which one's x2, y2. I usually just start, this is x1, y1, just because it's the first one listed, and that would make this one x2, y2. You might want to strategize if you like doing calculations a certain way, but that's up to you. I just make it automatic. Okay, so let's go ahead and plug these numbers in. So it is y2, which is the -2, minus the y1, which is the +2, over, so now we're x2 minus x1, so that's the 4 minus the -1. And let's do some simplification. So here we got the plus, -2 minus 2, that is -4. And then 4 plus 1 is 5. So my slope is -4 over 5. Okay, now again, I can use slope-intercept form or I can use the vertex form like I did in the previous problem. I'm just going to choose one of them. I'm going to choose vertex form. So that general form was y equals m times x minus x1. Again, it's just an altered form of the point-slope form. For me, it's a lot nicer this way. So y equals, my slope was the -4/5, okay, times x minus, now x1, y1 might lead us to think, okay, I have to use these points in the equation. And you don't necessarily have to really. X1, y1 in this case is just notation for any point that lies on the line. I could go with x2 and y2, but to avoid confusion, I'll stick with what I originally assigned. So my x1 is -1, so minus a -1, and then plus my y1 value, which is 2. And this is going to require some addition of fractions. So that becomes a plus, and then I distribute. I get y equals -4 over 5 times x minus, because the negative times a positive now changes back, so it's -4/5 plus 2. And then real quick off to the side, we're adding these values right here. So -4/5 plus 2, well, let's find a common denominator. So we want something out of 5. Well, something divided by 5 gives me 2. That would be 10. I can think of this also known as 2 over 1. Multiply this by 5. Multiply this by 5. You get 10 over 5. So -4 plus 10 is 6, and 5 is our denominator. And so we write out our final answer, y equals -4/5 x plus 6 over 5. Thanks for watching. If you like that video, go ahead and give it a like and subscribe to the channel. If you have any ideas for future videos, leave them in the comment section, and I will see you for the next video.